So we're here on the RFS stand with the VP of Marketing, Eric. And Eric, we're investigating various ways that operators can operate more efficiently. And at the network level, I think you've got three really good solutions to help them do that.
First solution for operators to cope with the increase of the traffic is to offload their traffic to indoor. Indoor is typically not well covered enough, right? And the reason for this is the total cost of ownership to deploy indoor coverage is too high. Operators are faced with issues, getting authorizations to do it, and they should not spend too much. Clearfield Star brings down the total cost of ownership of indoor coverage up to 40% down, right? Which is pretty massive. Give a great incentive to actually go into this direction. It's a technology that is relying on digitization, packetization of RF signal distributed over Ethernet cabling, which is the cheapest, most cost-effective way to deploy cabling inside a building, right? So, an innovation from RFS. The second side of thing is, once we have exhausted other ways to cope for with the data traffic increase, LTE, I would predict, around 2012 in most countries is the last time you need to be able to, launch LTE. This will bring you, more spectrum efficiency and more spectrum, right? More new frequencies. In RFS, we are bringing to market now ultra broadband antennas that mean, operators can actually start deploying their current, infrastructure, current technology using our antennas, which are ultra broadband, and start their trial in LTE later on in 2.6, right? Because our antennas are from 1.7 to 2.7 gigahertz, and they can start, using them for wideband CDMA 2.1. And then they can actually later on use them for their trial at 2.6, refarming their previous frequencies from the wideband CDMA, giving them all flexibility from 1.7 to 2.6 or 2.7 gigahertz to actually play with the different frequencies they may use for LTE in the future. We're using a completely new structure of the antennas, completely new dipoles to radiate across that band, still giving the same type of high, well-recognized high gain of our RFS antennas.
And of course, operators are also faced with the challenge of upgrading their sites, to get more out of what they have.
We've been very much involved into this renovation programs in the leading operators in Europe. And the real challenge really for the operators is as they upgrade their base stations or node Bs to latest type of software and features, they want to go remote read ahead because they want to save on energy, right? So they want to have the remote read ahead as close as possible to the antenna. Now, it is all good, but how do they bring the DC current that you need to power active components on the roof or on a tower? We have here developed a system that is actually a connector that is enabling operators to reuse the feeder cables, the RF cables they had previously, and when they go and renovate the site, they don't need them anymore, but they can use them, still using the energy coming from the ground floor, use the RF cables to actually go up the chain and distribute, exiting the DC cables from that connector, bringing the DC current to the different remote radio heads on the rooftop. This is saving a lot of energy, a lot of time, a lot of money in installation of new DC cables, and this is making life much faster for operators to actually deploy their new coverage. So that's what we call the DC Fit from RFS.